adding an example using the new Vectorized UDFs from Spark. And these are exciting because they mean that we get faster UDFs in Python. And this is really cool. I'm going to be doing it in the Sparkling ML project. It's just a small project which works to expose basic Python functionality into Scala as well, so that the Scala people can take advantage of our cool libraries. And now, one of the things which I've been working on is exposing Spacey, because Spacey is a really cool tool. And so we can see in the transformation functions file that there's sort of some basic ones. There's this Spacey tokenize. It's done with the sort of legacy non-vectorized UDF. So this is just a regular Python function here. And this just exposes, this function. There's a little bit of magic that's hidden behind the scenes, but that's okay. It turns out, though, that exposing things that are not one-to-one transformations with the new vectorized UDFs isn't really well supported. It has to either be a grouped input or we're sort of stuck in this one-to-one world. And so the documentation for this is actually in functions.py. We can actually, maybe a better place to look at it would be in the Spark project documentation, because that's probably what most people would look at. So if we go here, we go into Python, and we're gonna go and look for SQL functions module, and it's the pandas UDF. And so we can see here there should be a reference to the fact that, right. So pandas UDF, there's three types, and if we're doing the scalar conversion, which is the one where we don't have group data, this is very much what we're limited to. We're stuck with, for each individual element in our input, we can only have one element in our output. And that's not great, especially if you want to tokenize things, right? For one input, we would probably have, multiple outputs. And that's something we can do with group data, but that's not the simplest example. So we're going to stick to sort of a more simple example. We're going to look at making this work with just sentiment analysis from NLTK. And this will be good because it'll get me importing a second library. I'm just going to check in with people and make sure that the sound's actually working okay. Hopefully they'll say yes, and we can just keep going. Right, so we're going to go ahead and we're going to use, instead of doing my original plan, we're going to go ahead and we're going to look at the sentiment analysis from NLTK. And because it has to be just one type, we're gonna return how happy they are. And Boo is awesome, Boo is happy, and we can, or sorry, how positive, not happy. And so we're gonna make a pipeline stage that'll use the vectorized UDFs. It'll show you sort of some of the limitations with the simple option, and from there we can do something more fun. So let's go ahead and actually write some code. Okay, great. So it sounds like it's working for everyone. The only downside is I don't get my music, which honestly is a non-trivial part of how I stay focused while coding. But the fact that y'all are watching what's on my screen will keep me from going and just reading random shit on the internet, hopefully. I'm pretty sure my boss isn't watching, though, so I don't actually know if it'll keep me from doing that. We'll find out. How lazy is Holden? So, okay. We're going to go ahead and we're going to jump back into the Sparkling ML project, and we're going to go into this transformation functions place. Now, I want to be clear, you don't have to write your code like this. This is kind of a weird way to structure your code. I'm just doing this so that these can look like Spark ML pipeline stages as well as using the vectorized UDFs. If you just want to use the vectorized UDF, you don't have to do it anywhere near as interesting as this. And so we'll we'll keep the structure because it's sort of my personal goal for this project, but you shouldn't feel like the structure is necessarily the structure that you have to do in your own project. And it looks like for some reason my Git pushes are not being super happy. I had this happen before, and it was about some weird software that was running on my computer. So we're not going to debug that because that is probably not super exciting. But I will definitely push this up onto GitHub after we're finished. So let's go ahead and get this started. So I am lazy. So I tend to do this. This ignore Unicode prefix is just important because I work between Python 2 and 3, and I write a lot of doc tests. We're going to call this NLTK. Happy, not happy. Positiveness. It's a transformation function. Uses NLTK to compute the positive sentiment of the input expression. Cool. Yeah. We could write a doc test for it. I'm not really feeling it right now, but I probably should. Let's be a good human. Actually, no, whatever. Let's be a bad human, and we can be a good human later when I run out of coffee. Okay. So right now this is extending transformation function, and that's actually probably not the right base class anymore. That's an internal thing. I'm gonna have to probably make a special vectorized version of this, so we'll go ahead and do that. And let's keep the party going. So, yeah, that class method. So I'm making a function here, which can be used to receive the arguments from Scala, which is useful. That being said, since I'm just doing NLTK positiveness, I don't actually really, I'm not going to bother exposing any arguments right now because I'm kind of lazy, but that's okay. So let's see what I didn't actually bother writing one. Okay. And this is going to be our actual function, except this is not going to be input series. Yeah. So that's great. We're going to go ahead and annotate it with pandas UDF. This takes in. Let's double check. No, so we return. Yeah. So it's actually. Let's go ahead and actually write it out, just because then when I'm scanning my code, I actually know that I'm saying my return is double type, not string type, and that'll make a little bit more sense. S dot stir. Okay, so we're gonna go ahead and you'll note that in the last time I had this kind of weird little hack, NLP equals spacymagic.getLang. And this is mostly just because constructing the sentiment analyzer every time is kind of expensive. But since I'm getting an input series, this might actually not be too expensive. And I am a firm believer in only optimizing after I found out that I was wrong the first time. I'm a very lazy programmer. So we're going to go ahead and we're going to try and do... So when I was trying this out locally, we're going to want to do this. So equals sentiment analyzer. So I'm going to construct my sentiment analyzer, and I'm going to selectively auto download what I need. And this is just because I'm lazy, and doing proper setup work in PySpark is really annoying. It's gotten a bit better in 2.3, but it's not great. So let's go. It's a lookup error, so that's great. Except lookup error, and I actually have this. Right, that's the input that I wanted. So. Import NLTK dot download. So this is actually, reminding me about a thing. I have another project about making it easy to install PySpark dependencies, but one of the things which it hasn't really addressed is this NLTK download thing. And we have a similar thing in Spacey. So actually, while it's on my mind, I'm going to go ahead and GitHub interact coffee boat. So when I have a project, I mean there is a project that I work on. GitHub interact coffee boat. The interact. There we go. That's the one. Issues, new issue. And this is just a note so that I actually come back and fix this more properly in a way which doesn't involve me trying and capturing exceptions randomly in my code. Make it easier to specify required additional downloads. Like Spacey language download and NLTK. Like Spacey. Downloads. There we go. And so then whenever I get around to fixing this, or actually, if someone else is looking for an exciting weekend project, if you want to go ahead and do my job for me, you could go ahead and work on this code as well. And it's in the Interact project, which is pretty cool. There's a few other people working on it. I'm going to leave a note here. Hack Intel is fixed. Yeah, and I'm just going to assume that fixed it, and if it didn't, I'll rethrow the exception and we'll have fun. Okay, so let's go back here. We're going to go and look at the documentation for the sentiment analyzer, because my memory is flexible at best. Okay, yeah. So I have a sentiment analyzer, 4 sentences. Yeah, so we could turn this into a generator. I don't know what's going to happen if I apply the sentence analyzer on a series. I am lazy, and that might work. So let's try it. Let's see if that works. Best case scenario, it works. I have less code to write. Worst case scenario, doesn't work. We have a little bit more code to write. So return SID popularity scores. Oh, I entered insert mode by mistake. Input series, and then I want to go ahead and pull out explicitly the one which I'm actually interested in is called .pause. Okay. I mean, that could work. That could work. I am pretty lazy. So I could So I got two options now. I could write a test and then I can iterate in the test. Or I could start up a Jupyter notebook and iterate in the Jupyter notebook. You know, actually, oh, I'm missing this vectorized transformation function base class. Let's go and find this transformation function base class. I mean, that's actually, maybe we don't need it. Let's go ahead and make this transformation function. And, okay. There are clearly two schools of thought on how to best do live coding, and mine is that y'all get to see all of my mistakes because I don't have the time to prep to do this all nice and fancy like. Oh, we are going to need to update the setup file because we've got a new dependency. Let's go ahead and put that in before I forget. Sparkling ML setup.py. You'll note that if you want to use the vectorized UDFs, you do need PySpark greater than 2.3. You also need Arrow installed and pandas, but pandas should be brought in by Arrow. So those are good. Oh, I'm missing the imports, aren't I? Yes, I am. Yes, I am. Okay, what branch am I on? Ooh, that's bad. I'm gonna go ahead and get rid of some bad white space that I introduced. Okay. Add NLTK as a setup requirement. Ooh, actually, we also probably have and so I'm just adding it to both the setup.py and requirements file for NLTK. Add NLTK as a project requirement. And then I'm going to go ahead and so I both want to go and look at something that I have in my git stash, but let's not. That feels like cheating. We're gonna go ahead. Functions.py. So we're gonna from PySpark.sql.functions import pandas UDF. Okay. And yeah. Ooh, actually, source tilde PySpark activate. I want to be in my environment. Oh, I have a new machine where I haven't installed Jupyter yet. Oh no. Well, okay. I kind of want to do this in Jupyter really quickly because I like debugging in Jupyter. It's kind of nice, but if this ends up taking too long, we'll just write a test and debug it that way. I had to blow away my machine, unfortunately, and that was not the most fun. Yay, sparkling ML. Let's go. Oh, interesting. It looks like I don't have all the requirements installed in this environment, so let's go ahead and do that really quickly. Coffee is amazing. Yeah. We're gonna shift the focus over onto Boo while this installs. It's super exciting to install all of the Python dependencies for Spark. Yeah, this will take a second, I suppose. I guess while this is happening, oh, yeah. While this is happening, I can't really show you a lot because my poor little CPU is not having the happiest of times installing. But we can go ahead and we can look at what it looks like in the Scala code while we're setting up the Python requirements. So the Scala code lives in src. I think I put it under feature. Maybe not. Maybe not. Right, and so this is a little bit of a hack. As you can see right now, each model that I write in Python, I have to write essentially this boilerplate, which is not the most fun. And this is a base Python transformer. This is probably one which we'll have to change. Unless... Let's go look at this base Python transformer. It's apparently in util Python. Python transformer. Oh yeah, okay. And so this assumes that the Python UDF it's getting back as a user-defined Python function. So we're gonna have to extend this because we're actually gonna get back a slightly different type. But that's okay. We can go ahead and customize this. The transform schema part, that's pretty much the same. Oh, okay, that's where we were using that. So actually, now that I see where I'm using the output data type, I'm going to go back into my whatever transformation functions and make sure that I actually do implement the return type. Class method. Return double type. This is because it's the return type information here is being used in the construction of the Spark ML pipeline stage. And so this is the base Spark ML pipeline stage that we've got. So that's not bad. Let's see if it's set up yet on the Python side. Okay, cool. It looks like it probably is. Probably have to restart the kernel. Import PySpark. Oh, no, okay, we're good. Yay! Okay. So, I mean, one of the reasons why I just like doing my debugging like this in a Jupyter notebook is it makes it a lot easier to just like go back and rerun everything than when I'm just developing in like a regular Python shell. So I like doing my debugging sometimes in a Jupyter notebook. I mean, it's a matter of personal preference. You do you. So that's great. And I forgot what software I was writing because it's been a long day. NLTK positiveness. Cool. Let's go ahead and actually import that. Positive function. Positive class. Cool. Sparkling ML dot transformation functions dot positive. Ooh. Transformation underscore functions. Okay. Yeah. From sparkling ML dot transformation underscore functions import NLTK positive. Cool. Ooh. Okay. That's probably functions has an S in it. Yay! Cannot import name. NLTK positiveness. NLTK. Ooh, yeah. We're actually just going to go ahead and rename this to a thing that I can type. Cool. And now we go ahead, kernel, restart, and run all. Cool. And then this goes NLTK pause. NLTK pause. Yay. Func equals positive class dot func. And we don't actually pass in any arguments because we're not expecting the Scala side to pass in any arguments either. Oh, fuck. It looks like I forgot to actually return the inner function which I built. So that was my bad. Let's go ahead. We're going to have to kernel, restart and run all. Yay! Yay! Okay, func. Cool. Sparkling ML, transformation functions, functions.inner. That looks more or less like what I was expecting. So now we are going to go ahead and we're going to jump back into functions.py to see how people actually use this. So we can see here, we can create a data frame like this. I'm gonna, oh, actually we need to create our Spark instance. Let's go ahead and do that. Import from PySpark.sql, import Spark session, I think, yeah, session equals Spark session dot get. That's dot builder dot get or create. Fuck. For someone whose job is working in Spark, it's surprisingly annoying. Spark session dot builder dot get or create. Okay, yeah, we don't actually pass params to builder. That's fine. Now I got my little session. Let's double check that I actually have my session. Yay! And I can click on the Spark Web UI. Ooh, let's not do that. We can open our Spark Web UI in a new tab. And we can see, that's not going to work for reasons that are not overly important. I can deal with that later. We're going to go ahead and close that. Whatever. If I disabled some things, that would work. But it's bound to one of my Docker IP addresses. So can't look at the Spark Web UI right now, but otherwise it's looking pretty good. I've got my session, and I can go ahead and create a data frame to test this with. So df equals session dot. Oh, I'm gonna try and match the input that we had in functions.py, just because I'm pretty lazy. Actually, this is not really all that great. We're gonna go ahead and swap this out for who is sleepy. And this is little Boo. She's with me, but she's definitely getting a little bit sleepy. I'm pretty sleepy too. Who is hungry? And who is happy? So hopefully, we'll see the results that we expect. Well, I mean, hopefully our code runs, let alone seeing the results we expect. So ID and sentence. ID and stir. I am lazy. That's great. Oh, yeah, this is... I'm going to just double check that I actually... df.show. Got what I expected. Just want to double check that everything is fine. Yeah, that looks great. Result equals df dot select. We've got our function, which is an inner function with the attribute on it. So we're actually gonna select the string because I want to see what it is. So select stir and func. Is that gonna work? We're gonna find out. Dot alias. Cool. That nominally worked. Result.show is where the rubber actually hits the road, and we see if this actually runs. And it looks like no, it does not run. So that's all kinds of sadness. Let's go find out. Oh. Truth value of a series is ambiguous. Oh, right. Okay, so one of the things that you'll notice is the error message is reported in here. Sometimes leave a little bit to be desired. And so sometimes I jump back in here. This has improved a lot in recent years. It's just an old habit that, I kind of stick with. So it says the truth value of a series is ambiguous. Use a.empty, a.bool. Okay. That's cool. If I had my... okay. I'm actually going to go ahead really quickly, switch this into waiting mode, so that I can access my... back to live. So now I can access my Spark Web UI again. Cool. And we can see that I have a failed job in my Spark Web UI. I'm going to go in, clicky. It failed inside of the driver. And so, yeah. It failed here, which honestly not that surprising. Let's go ahead and refactor this code really quickly. My guess is, yeah, it looks like the NLTK sentiment wasn't designed to be passed a series, and so that's fine. We're gonna go ahead and just turn it into a series ourselves, and so that's gonna be great. Okay, I'm gonna drink some more coffee though. It's already 3:50. About right. So the important thing to note is that we're actually in our transformation functions. Our input isn't just a string anymore. This is actually a series. And so that's why we're having the sadness over here. And so we're gonna go ahead. We're gonna map sid dot polarity scores over input series dot stir. And we're gonna lambda result. I wonder if I can do this with a map or if I need to use apply. I don't remember, and it's faster to just try it. Yay, kernel. Restart and clear output. Oh, actually, no, I wanted to restart and run all. Damn it, but whatever. Run all. Ooh. Yeah, not like that. Unveiled job. Show string. Okay, probably have to use the apply syntax. Series object has no attribute in code. Interesting. Yeah, alright. Transformation functions up by. Let's double check. Pandas, series, apply. Okay. Yeah, that's what I wanted. Yeah, so we're gonna go ahead and swap this into is equal to input series dot apply. Oh, I just deleted my lambda function. Okay. Input series dot stir dot apply. Polarity scores, and then cool. That looks like it's sad. But okay, go back. Kernel. Restart and run all. Yay! So we went ahead and we switched our map into an apply. So I'll extract the result this way. I hope this is the right syntax. Switching between languages all day does give me an excuse to make a lot of syntactical mistakes, which I'm clearly making. Okay, let's go ahead. Reload this. Ooh, we have a different exception. String methods. Oh. Damn it. Why did I call it stir? Let's go back here. It doesn't. do. Alright. Let's go and find out what I did wrong this time. Series has no... Okay. That should be what I expected. Why was I calling .stir on this? That's a good question. Is it just purely a native series and I don't have to... Oh, yeah, okay. I need more or less coffee. I'm not actually sure which. Let's assume that's gonna work. Nah. Restart and run all. Restart and run all cells. Cool. Okay, looks like it failed. Hopefully it failed in a new and more interesting way. Let's find out. Ooh. Failed on all three of them. Oh, so, yeah, okay. So that's I guess we'll just switch this in. I want to extract the field, but it's probably just easier if I do lambda sentence. Cool. Kernel, restart and run all, restart and run all. Yeah. Yay! Okay, so we can see now it works. That's exciting. It's been almost exactly an hour. I do not know how I get that to be on the dot. I'm very, very excited because I'm very, very lazy. But we can see that Boo is sleepy has 0 elements of positiveness. Boo is hungry has no particular positiveness. But when Boo is happy, it has 0.649 elements of positiveness. It seems a little low, but I mean, given this, that works. So that's exciting. We now know that it works for working just in Python. So let's go ahead and commit this. Git commit am add pandas based UDF for NLTK positiveness. So that's great, but now we need to go back and fill in some things. One of the things that I want to do is fill in the doc test, and the doc tests here, you'll note, are not actually being done. If we look at the other methods in this transformation functions, the doc tests here are not actually being done on distributed data frames. The doc tests are just being done on local data frames. That way we can run these doc tests more quickly. And since our input here is going to be a series, we're going to want to use a panda series for our input. Let's go ahead and actually... I'm lazy. Import pandas. Oops. I don't actually know why I have... Oh, I remember why I have eginspect imported. Okay. So input series, we'll do sentences. I'm gonna jump back into the panda series documentation. Yeah, pandas dot series is going to be Boo is happy, Boo is sad. To a list really quickly, and then my func is equal to nltk pause dot func. Like I said, this is really awkward syntax. This is just being done so that we can call it over here from our Python transformer in the Scala code. But let's go ahead and make sure this part works. I'm going to actually, this test doesn't work. Since I never actually trust my software, I'm going to go ahead and just run it like that. Just to make sure that my test actually fails first. Oh, that was not what I wanted. That test, right. I just remembered I actually test this stuff with nose. So let's run the build and package shell script, which I have, because I never remember my magic invocations. This also ensures that I have the dependencies downloaded. And it looks like I clearly didn't have the English dependency downloaded for Spacey, so that would have failed. This is going to run Scala style as well, but whatever. Let's leave that to run. We can finish our doc tests in a second. Ooh. Okay, incidentally, it ran PyCode style, and turns out I wrote some really crappy code. So let's go in and fix that. Line 124. Ooh, this is some older code. Okay, whatever. That's fine. That was kind of a hack. We'll pretend that did not exist. Oh, yeah, that is. Okay. Let's see here. Okay, line 192. Too many blank lines. Cool. Yay! That works. Oh, I should probably change this to only install this if it's not needed. Sorry, GitHub servers. It's okay. Not that many people use this build script. It's pretty much me and one other developer. You're fine. Cool. Oh no! Oh, Boo is falling over because I stole her coffee. I'm really sorry, Boo. She's gonna come and join me like a parrot and sit on my shoulder. Oh, okay, she doesn't want to do that. Boo's sleepy. Cool. We're compiling our Scala sources. See if this part works too. Hopefully, I mean, my Scala code hasn't broken because we didn't touch any of the Scala code, but I mean, it is a multi-language project, and those things are pretty much magical, so there's a chance that we did accidentally break something without meaning to, which is actually a good reminder. There's this really sketchy functions info thing that I use to sort of do kind of not so great registration-like functionality. So we're going to go ahead and put an LTK pause in this. And LTK pause. Cool. And actually, one of the incidental things about this is I don't like this restriction that we have to have only one-to-one inputs. I think it might make sense to expand the Scala options a little bit Certainly, we can get some faster stuff with it. But I've been meaning to, and I don't remember if I did, I've been meaning to make a Jira issue to track this. So while this is building, I'm going to go in and check inside of Spark to see if any of the issues that were reported by me are the things covering this. And so yeah, this one is a thing that I care about. I'm going to actually CC my good friend, former coworker, CC Brian Cutler, for thoughts. Just because he's been working on this, and it's a thing that I'd like to get in. But if Brian tells me that, this just really isn't on his roadmap, that's fine, and I'll just work on this code myself. So we can see here that I do have an issue for this, and it's definitely no one's going to do it but me, is the short version. It's created 6 days ago. No one's really working on it. But if someone does want to work on this issue, you can totally do that. Hopefully I've stalled long enough. Yay! Okay, we got our one test failure, which is more or less what I was expecting. And so that is great. That is great. Oh, that doesn't, not a string or column 0. What? Java column. What the hell is this code doing? Wait, did I actually... This is going... Oh! Damn it. It seems like the trick that I was doing to doc test things more quickly does not work so great with our annotations here. So that's all kinds of fun. Let's see what we could do to work around that. I mean, the simplest to work around it would just be to, turn this into a data frame. But that's work, and I'm lazy. The other option would be to make this into a vectorized transformation function based class, where we actually go in, grab our return type, and then wrap our result with the annotation, which, I mean, that might actually be not a bad plan. Because we don't seem to put the annotation on in the other places. So that's probably what we were doing anyways. This construct UDF. Let's go in. Some of this is dealing with code that I really don't remember writing. I mean, I clearly did. Yeah, okay. That's cool. We're gonna go ahead and we're gonna take off our annotation, and we will deal with this later. Or more actually, yeah, okay. Transformation functions, we are gonna go ahead and get rid of fancy annotation, sadness, and instead we're gonna put this in the vectorized functions info. Super fancy, slightly different global. Yay! If we look inside of this one, this is where we expose this spacey transformer. So I'm just gonna go ahead and take a look. Yeah, so that's what we were doing here. Okay, that makes sense. We'll not use the annotation, even though it's nice. And you should probably use the annotation yourself. It just doesn't fit so nicely into this weird architecture that I have for exposing Python code into Scala and Python at the same time. And we're going to go and dive into the belly that is startup.py. So startup.py is essentially this magic to provide an entry point for Scala to call to register the functions. And this is because when our Scala code starts up, it's not being called, from Python necessarily. We want people to be able to include our jars to have a fun time. And so this requires, okay, actually, yeah, we're just going to use the same one. We're just going to use a different type because 2 globals makes Holden's twice as sad. Yeah. Class vectorized transformation function extends transformation function. Transformation functions which Scalar vectorized, which are Scalar vectorized UDFs. And this is just so that our startup code can know which path to go down. So that's cool. I'm going to go ahead, swap this into Scalar vectorized transformation function. We're going to go over good startup.py. Function info. Okay, so far this is all more or less what I want, and it's going to be down here where we do our trick. Oh, it looks like Emacs is upset with me for reasons. If is instance function info scalar vectorized transformation function. That's cool. I'm lazy, so we're just gonna swap this around based on the type. We're gonna go ahead and jump back into functions.py to look at it's the pandas. It's pandas user. Is that the pandas user defined function? This is the PD. Yeah. Let's go ahead and look at what's actually happening inside of this code. So the problem is I want access to the underlying Java UDF, and this underscore create UDF is bad. So I should note, this is depending on internals and is generally speaking a bad person thing to do. And TLDR is I'm a bad person, but that's okay. That's my job. This gives me back, great, almost exactly what I want. But then it goes ahead and wraps it. That's probably fine, which is obviously the definitely never a problem. Whatever. Okay. Yeah. So we're going to take our function here, which is just going to be called func, our return type, which we've already extracted as ret type, and our function type here is going to be scalar. So that's going to be so much fun. Pandas UDF type dot scalar. Cool. We're going to need to add some imports for this to be happy. Oh man, I don't remember why I did it this way. It's making me kind of sad. But that's okay. PySpark pandas UDF type. It's rockin'. Cool. Oh shit. I didn't want to. That's way too much work. We're just going to go ahead and run our nose tests really quickly. And then we're going to go ahead and run some more tests. Nose. Nose is slow. Oh, nose is slower when I forget to press enter. Cool. While that runs, let's sit and actually, I'm interested in looking at udf.python to see what underscore wrapped is doing. Oh, this is, yeah, okay, this is fine. That's fine. Oh, cool. This is useful. We should probably put some interesting doc strings then in there. I forgot that we fixed that. Yay! Okay. Expected this doesn't work and got something else. Cool. That is more or less what I want. And yeah. So okay. So, test work, dot, yeah, okay, really, I want anything except for a 0 here. I don't remember how to do regexes in doc test. Let's look that up. Can I do a regex inside of a doc test? Regex? That's not looking promising. This is probably fine. Or actually, I could do a math.ceiling, which would be kind of a hack, but it would make my doc test reliable. Or I mean, it should. I can't spell for shit. Math ceiling. Yeah, I cannot spell for shit. Okay. Oh, it's math dot apply. This is a bad doc test because we really wouldn't expect anyone to use it this way, but also on the other hand, this is like my own open source project, so it's fine. Cool. Let's go ahead and rerun our nose tests. I should check my chat and see if anyone says anything. Oh. There's Bailey. Hey, Bailey. Okay, cool. So as you can see, we actually, these Lucene analyzers that we're all checking right now are Lucene's written in Java, and so we're making sure that we can call those. And it looks like, oh, I misspelled the word apply, so I'm really kicking ass today, and I definitely probably should have eaten more than a tin of soup for lunch. Rolling, come on. Okay, what was I doing before I got distracted? Whew. Kids, this is why self-medicating with coffee is not enough for ADD. But there we go, stage 171. Doc tests. Cool, yay! That's great. Cool. Git commit -am. Switch how we construct the vectorized UDFs so we can do the fast doc tests for the vectorized UDFs as well. Cool. That's mini progress. But it's really, we don't know if the important part works. So we're going to go ahead and we're going to take NLTK pause and we're going to expose it fully in Python first. We've done some of the wiring up to expose it in Java, but we're going to expose it as a Spark ML pipeline stage. And I think I talked about this earlier, but I realized that maybe not everyone's familiar with those. So Spark ML pipelines, we can see here, I'm going to zoom in a bunch so that people can read this code. But there's transformers and estimators, and a pipeline can chain together multiple transformers and estimators. And so they actually look a lot like scikit-learn pipelines. The only difference is they're working on distributed data, and we don't have a lot of useful functionality. But if we make it easier for people to do stuff like this, hopefully we can just start slotting in scikit-learn elements into Spark ML pipelines, and everyone can have a party. So let's go back, and I need to get back inside with my own code rather than the Spark code. So we're going to go up into feature and Python pipelines, and it's going to look a lot like the spacey tokenized pipeline. These things have a lot of parameters on them. I'm not going to bother with any for now, but just, well, I mean, we're going to have the input and output column because we pretty much have to. Yeah, that's fine. And so this will give us our first test, well, beyond what we did in the Jupyter notebook, that this actually works on distributed data. NLTK pause transformer. Determine the sentiment, the amount, the positiveness of the sentiment of the sentence input. Okay, hi boo and bye boo are not really great, so we're gonna go boo is happy and boo is sad, because these are gonna give us sort of better results. Input columns, files, output columns, C. I don't remember why I was doing this. We're actually just going to go ahead and simplify this into .show. And we'll deal with that later. Once again, this test should fail. And we'll make sure that it ends up looking kind of like the numbers we saw earlier. If it doesn't, that'll tell us something sad's happened. So that's great. That gives us the doc test to start from. I'm going to go and look at... Oh. Why does it underscore transform? I'm trying to remember. Okay. Yeah, I'm trying to remember if I need subparams and init if all we're using is default fields. There's a good chance that we might. There's also a chance that we might not. And I'm a firm believer in writing code after my tests have yelled at me to tell me that I'm making mistakes. So let's let our tests do the job for us of telling me what it is I have to do. So we don't actually have any setup code. And our functions are actually pretty much... Yeah, they don't depend on any parameters, so that simplifies things a lot. Okay, and I'm back. As you can see, it's the tests are passing, and that's good. But we still don't have it plumbed through to Java. So we've got it working in Python now, and that was just done with this underscore transform function, calling the pandas UDF with the return type that we defined over inside of this transform functions. And then this is just the general pattern that you do for ML pipeline transformers. So that's pretty cool. We have an ML pipeline stage for computing how positive the sentiment is for a given sentence using NLTK. But let's go ahead and get the Java folks to have access to this. I don't super know why, but yeah, let's do this. We're going to go back into here, and we can see that the functions info is NLTK pause. We're going to go and jump into our Scala files, and I don't remember, probably Python transformer.scala. So there's a chance this might work as instance of user-defined Python function. Also, I'm sorry for the noise which is about to happen, but I'm really hungry and I want toast. It tastes like toast. This type might not match up, but if it doesn't, it'll give us an exception and we'll find out what type it is. So other than that, we're actually looking pretty solid. This is kind of a hack. We're not going to talk about why that's sad. Instead, we're going to go ahead and jump into feature transformers. Look at our basic Python transformer. And our absolute simplest is strlen plus k. And we're actually going to be even simpler than that because we don't have a k. And so our transformer function is going to be an LTK pause. So let's just go ahead and do this. An LTK pause Python. So there are no parameters. Python function name is an LTK pause. Our output type is a double type. Our input type should be a string. Yeah, it's more or less what we're expecting. Copy is default copy. Minimum serialization is just the empty string. So we have no parameters to serialize from Java into Python. So that's great. Let's go ahead and jump into the tests. Alright, once again, I am lazy, so we're just going to copy pasta as much of this as we can. Verify that the transformer runs. Sure, that sounds like about what we want to do. Our transformer is called NLTK pause Python. NLTK pause Python. We don't have a parameter to set. We do want different input data. We want hi. We want boo is happy and boo is sad. And don't really care about the word boop. That's fine. So the first thing is that boo is happy. Because this is a transformer, we expect in general in Spark pipelines, we just add things. So we expect our input data to still be there. So we expect to see happy and sad come through. We expect to see 0649 and 00 come through here. But let's make sure that our tests are running. So I'm going to actually set these both to 00. just to make sure that they fail. And let's go ahead and start up the SBT console. Cool. Oh, the peanut butter's a little toasty. Yay! It works. Turns out I also had myself on mute for a really long time. Sorry about that. But it works, and so that's awesome. Let's go ahead and see if the big tests work. Okay, some style issues. That's pretty much fine. Python. I'm really lazy. I'm pretty sure that it will still work. I really need to fix that. Let's go ahead and make an issue for it, because I'm not going to get to that. Fix build and package script to only download spacey en language when needed. Right now, it does it every time. Looking promising. There are a bunch of warnings that we're just really not going to deal with. It's not the end of the world, though. They're all pretty minor Scala style issues. Okay. Running the nose tests. That's good. Spark UI could not bind to port. That's fine. We're already running Sparks. That's more or less what we would expect. Looks like it's running. Okay, cool. So we're able to call most of the Java transformations. That's reassuring. We wouldn't expect that to break, but as I've said before, it's a cross-language project. You get sort of unexpected behavior. Okay, and so that was the real big test. Is we just saw the NLTK one go by, and that worked. That being said, there's some didn't work completely. Oh right, because I changed the text. God damn it. We're gonna go ahead and just copy pasta this over. And yeah, I mean, yeah, that's fine. I'm pretty lazy, and that's good enough. Oh, every time I see this download, I think I should fix it. Every time I see it, I don't. In my defense, I haven't seen it that many times. I only recently added it to the build script. Yeah, okay, we also need to fix pep8 to reference PyCode style. Switch pep8 references to PyCode style. It's renaming. Cool. I mean, this is the grand tradition of software projects. We fix one bug and we find like 3 other things that we should fix when we're done. well, I mean, actually, I guess we're not fixing a bug so much as we are adding a feature. So that's exciting. For values of exciting, which have a certain flexibility associated with them. Looks like the stream may have just crashed, which is fine, but I'm not really sure. Yeah. Oh, no, okay. It looks like the stream is just running a little slow. But that's fine. I like toast. Yeah, sorry, my attempts to save you from the sounds of me chewing toast really didn't work out at all. But the exciting thing is, our Python test passed! Yay! Excitement. Excitement. Now we're going to see if it can be called from the... Oh, I ran out of coffee. So I really sincerely hope that this works from the Scala side, because if it doesn't, I'm going to have to put on pause and get some more coffee, but I'm really hoping that this will finish. I can go get a wonderful cup of coffee, and then we can go ahead and have that party. Yeah, once again we can see it's using a different interface than the one I want, but that's fine. Lazy. This waiting for friend is because we're doing a weird backwards connection. We can see Sterling plus K worked, spacey tokenized worked, shared params cogen chest. Ooh, yeah. This is looking super promising. Super promising. Still very promising. Lots of languages to test. Okay. And everything finished. Echo $sign question mark. Oh, yeah. Look who got the Velcro. Okay. So, well, okay, we're going to commit these differently. We're going to commit this one on its, well, we'll commit these two, because these are sort of one logical change together. Ooh, my computer is not having a great day. Git commit-m. So, refactor away from is subclass to instead defining the val type inside of the classes. And this is easier because then, you know, if someone wants to add a function, they don't have to edit startup.py, and so even if we don't work together, it'll be a little nicer. Leucine analyzers, that's great. I don't actually oh, fuck. Wait. I'm not super sure why Leucine analyzers changed. I don't remember changing this. But also, looks fine, and I don't really care at this point. Okay, but let's separate that out. Oh, right. Okay, so the Leucine analyzers are actually auto-generated. So we're definitely going to commit that separately. Commit-m. What's this thing? Change text to fit on a line for doc test because I am lazy. Feature Python pipelines.py. Okay, git diff again. Git commit-am. Rerun auto generation for Leucine analyzers. Cool. That's great. Let's do a git push. Oh, right, the git push might still be broken for reasons that are not super particularly important. And I'll debug my work environment settings to make sure nothing's stepping on its toes. So I guess that is finally it. That took longer than expected, but that's the way of life. This is Boo. Boo. Boo says bark bark. And we hope to see you next time. I'm going to do a live stream code review again on Friday at 11 a.m. Pacific. And I'll probably do some more live coding later on. I'm not super sure what my schedule looks like this week, but I'll try and do some more live coding to integrate Spacey, and you can explore with me the grouped data type then. And so that's pretty much it for me. Thanks everyone for bearing with me throughout the muted microphones and the other weirdness with my headset not working super great. Have a wonderful Monday or whatever day it may be where you are. Cheers.